So now I have to make sure that I'm not doing it. All right, we have a lot to do today. And we were right in the middle of something really cool when we had to stop last time. So what I would like to do is have you get your notes back out. And let's look at in the 4.4 notes, we're looking at problem 2B. Problem 2B. So dig those cobwebs out of your minds here for a second. And let's see if we can remember what in the heck's going on here. Okay. So we've got this picture, and our job is to write an equation for this picture. And the equation that we write has to be a sine or a cosine. And we're actually going to do both. Do you remember from last time that there are really 4 different adjustments we can make? We can make an amplitude adjustment, I'll say sine. We can make a period adjustment. We can make a horizontal shift and a vertical shift adjustment. So in our trigonometric equations, whether they are sines or cosines, or really tangency to any of them, we can adjust them 4 ways. We can stretch them and shrink them this way. We can stretch them and shrink them this way. We can pick them up and move them this way. We can pick them up and move them this way. So the numbers in the equation make those changes. So let's look at this one. When you just see that picture, understanding that it does go on forever and ever, but when you just see the part that's drawn there, what do you think of? Cosine? That's what I think of. So I'm going to start here. I see a cosine here. My solid blue is a cosine. All right. It looks like its amplitude is 6. It's a positive cosine. Positive cosine start at the top of the hill, so I don't need to worry about a negative there. It looks like it has been shifted pi over 9 to the left, which means inside the parentheses will be plus pi over 9. Right? That's your horizontal shift. It doesn't look like it's been lifted up or down at all, so I'm going to put a 0 there. You can tell that real handily because top point's 6, bottom point's -6. So it hasn't been shifted at all. It's just doing what it does. Now I have to find the period. I don't know what that number is right there. But I know that the normal period is supposed to be 2 pi, but if I divide it by this number, it gives me my new period. So 2 pi divided by this number, this is a divider number, so 2 pi divided by that number gives me my new period. Okay, well what is the period of this picture? How far is it from the top of the hill to the top of the next hill? 16 pi over 9, -1 to 15. So 2 pi over n equals 16 pi over 9. In every equation of a sine or a cosine, 2 pi divided by this number gives you your period. I know my period is 16/9, so I'm figuring out what I divided by. So 18 pi equals 16 pi n, cross multiply. I'm solving for n, so I'm going to divide by 16 pi. So what did I get? 9/8? Does that seem right to you? Now here's the great news. When you go to make this a sine equation, isn't it exactly the same picture, you guys? It's the same picture. The difference is you're going to start it in a different place. So you might start it here. That's a piece of the same curve. So it has all the same features. Its amplitude is still 6. Its period is still 16/9. Its vertical shift is still not there, 0. The only thing that's different is, if you're looking at the pink curve, then your phase shift is different. Your horizontal shift is different. Now you're starting at pi over 3. So this would be x minus pi over 3. And because it went down first, that 6 is going to have to be negative. This problem is a grading nightmare because there are other answers besides these. Could I have chosen to start my sine curve here? Yep, that would be a positive sine curve with a phase shift of 11 pi over 9. Could I have started my cosine curve here? Yes, there are infinitely many different equations that you could write for that curve, all depending on where you started looking. The only thing that'll be different in all the, I said it's a grading nightmare, it's not that bad. The only thing that'll be different in all the possibilities is sometimes this is positive, sometimes it's negative, and this will be different. Everything else stays the same. Same curve. Does that make sense to everybody? Okay, that is good stuff. All right, now let's see what we've got in number 3. Sketch one period and list all the requested info. So what I'm erasing right now was a picture that you wrote the equation for. Now we have an equation and you're going to draw the picture. A lot going on here. Just make sure you understand all my hieroglyphics here. Period, amplitude, phase shift, vertical shift, frequency. I don't think we talked about that yet, so we will. But let's see if we can get this picture drawn first. Tell me what we know about the picture we're getting ready to draw. We know that it's shifted pi over 6 to the left. So I'm going to start my sine curve. It's a sine, so I'm going to start it right there. If it were a cosine, I'd start it up here. Now, I'm going to hold off on that for a second. What is that going to do? Ultimately, what's that going to do?
Shift it up.
It's going to shift it up one. I'm just going to wait on that for a second. What does that tell me, that -2 right there? That it's going to go down first to our highest and lowest it's gonna go. So far, so good. Remember, I'm doing that pink thing last. All right, now I need to do, I'm really pretty much done, except I need these labels in here. And I can't really figure those out unless I know what my period is. Period's gonna be the distance between my fingers. We just talked about it. Period will always be, for a sine or cosine, 2 pi divided by that number. So the distance between my fingers is 2 pi over 3. Which I might think about, this is up to you, but I might think about that as 4/6. Now why is that easier for me to think about as 4/6, Jake? Exactly, and I know that from here to here has to be 4/6. So this one's gonna be 3/6, because -1 plus 4. Does that make sense to you? Now, right in the middle, what's -1 plus 3? 2, and half of 2 is 1. So this is 1/6. Oh, let me move this a little bit. What's halfway in between -1 and 1? 0. And what's halfway in between 1 and 3? 2. The lowest point of this curve was at -2. It's getting lifted up 1, so won't the lowest point now be at -1? The starting point was at 0, now it's going to be at 1. This is going to be at 1. Now the high point was 2, now it's going to go all the way up to 3. And there is my final picture. Now, I don't care, and you don't have to sketch this the same way I do, I mean in the same sequence of steps, as long as you're ending up with that pink picture, perfect. If I'm doing this on a test or quiz, I've got my colored pencil, and I just somehow mark that that is the answer, because that is the final answer. Now, we're going to fill in the rest of these. Okay, what can you fill in? What do you know? What's the period? 2 pi over 3. What's the amplitude? 2. What's the phase shift? Another word for horizontal shift. -pi/6. Now, you either have to say negative or you have to say left. So we know which, that we're going this way. How about vertical shift? How much should be shifted up? 1. +1. And 1's fine. That's +1. We went up 1. If we'd gone down 1, we would have to say -1 or down 1. Now, what's frequency? Frequency, by definition, is the number of cycles completed in an interval 1 unit long. Now you go ahead and write that down, and then I'm going to try to show you what that means. Not in terms of this picture, but in terms of a simpler picture. let's look at a couple of sine curves here. If we talk about an interval 1 unit long, how much of a sine curve got done in that interval? Did a whole curve get done? No, just half of it. So for this picture, the frequency is 1/2. I want you to notice something. What's the period of the curve? Well, 1 hill and 1 valley, the period of the curve is 2. A hill and valley, that's a period. All right, look down here. What's a period of this function? 1. Oh shoot, this is a bad example. How much gets done in an interval 1 unit then? In that 1 period? Whole curve gets done in 1 interval? That doesn't help too much, but this one does. What's the relationship between these two? They're reciprocals. Are these two actually reciprocals? Yeah, it's not a very good example, but it's reciprocals. Yeah. So frequency and period are reciprocals. So if your period was 2 pi over 3, then your frequency is simply 3 over 2 pi. Frequency and period are reciprocals. Let me change these numbers here on this one for a second. I changed it. This is 1/4, 1/2, 3/4, 1, and so on. So the period of this is 1/2. But if I look at a whole unit, don't I get through 2 cycles? So the frequency is 2. They're reciprocals of each other. Period and frequency are reciprocals. Do you remember the other, I can't remember if this is class or not, but when we increase the amplitude, or when we change the amplitude of these waves, that's like turning up the volume. It's like making them louder, the sound waves. When you do this, it changes the pitch of it, makes it a higher tone versus a lower tone. These are sound waves. And changing, okay, perfect example. How many of you, this is really old fashioned, but how many of you know what I'm talking about when I say AM radio and FM radio? Guess what the A stands for? Amplitude modulation. AM means amplitude modulation. So when you're broadcasting on an AM station, you're talking about modifications to the amplitude. Guess what FM stands for? Frequency modulation. So when you're broadcasting, I know, isn't it awesome? When you're broadcasting on a FM station, you're dealing with changes in the frequency. Okay, all right, so one more, let's do it. Let's see what we can come up with here. Okay. All right, here we go. Now, I got a little bit tricky on this one because, see that 3 right there? He actually needs to be outside the parentheses. So before I start graphing, I'm going to factor the 3 out. He's holding his head. Now, we are big kids. We can handle this. If I pull out the 3, I'm going to be left with x minus what? Pi over 3. Somebody said it. Now, okay, all right. Even if you don't get it, folks, check it. What happens if you multiply 3 times pi over 3? Don't you get pi? Well, that's the point, right? So if you don't understand that factoring is division, that's what factoring is, it's division. So when you divide out or factor out of 3, you're dividing out of 3. Just mess with it until when you multiply it back, it works out. So here we go. This is a positive cosine curve. Its amplitude is a half, at least to start with. I know it gets bad, I'm gonna take care of that in a minute. Bless you. The phase shift is pi over 3. So my picture is going to start right there at pi over 3. Right here, it's a cosine. Starts at the top of the hill. It's going to come down and back up, and it's going to end right there. Remember, I'm doing this part last. Are you with me? Now, before I can figure everything else, I need to know my period. So my period should have been 2 pi, but I divided by 3. So here to here is 2 pi over 3. Since I started at 1 pi over 3, won't this be 3 pi over 3? Now, you're thinking, can't you just say pi? Yep, you sure can. I'm going to say 3/3 because now I have to find the middle one, and I'm going to do that by adding. So what's 1/3 and 3/3? 4/3, and half of that is 2/3. Here comes one of those tricky ones. 1/3 and 2/3 is 3/3. I need half of that, so it's actually going to be 3/6 or 1/2. You can't cut 3 in half, so you need another fraction. Same thing here. 2 and 3 makes 5. Can't cut that in half, so it's going to be 5/6. We okay? Now, I did not plan well because I need to drop that down 2 whole units, right? Yeah. So there's -1, there's -1.5, there's -2, and there's -2.5. All right, that should do it for me, but I'm clear down low. You might not be able to see that, some of you in the back. I'm going to take each one of these points and drop it down 2 units. So this point's coming down to -2. This one's coming down to -2. That one's going down to -2.5. And this one's coming down to -1.5. So I'm sorry I didn't plan well. Here's my curve, drop down 2 units. Period, amplitude, phase shift, vertical shift, and frequency. Here we go. What do we know? What can you tell me? Fill in those blanks. Those are points, by the way, on test set. So let's fill them in. Period is 2 pi over 3, which means frequency is 3 over 2 pi. Perfect. Amplitude, 1/2. The height of those waves is 1/2. That doesn't change because you moved it. The amplitude is still 1/2. Our phase shift is pi over 3, and our vertical shift is -2. Remember, you either, when they're negative, you either have to say negative or you have to attach a word, like down or left. Okay? All right. Before I erase that, last question on that problem before I erase it, we have one more to go. As soon as we do problem number 4, I'm done for the day. Okay? Hang in there. You can do this. let's draw a picture of what's happening here. A particular July 4th, high tide occurred at 9:36. At that time, the water at the end of the pier was 2.7. Low tide occurred here at only 2.1. So, I'm gonna go ahead and put times down here. So, and I'm gonna make my times decimals. I think that might be easier for me. So can anybody tell me what decimal 36 minutes would be? 36 minutes. What decimal part of an hour? Can you figure that out?
36 over 60.
Yeah, so what is that? 36 over 60? I should know that.
3, 9, 15, 3,
0.6? So here's 9.6. Here's 9.6. That's 9:36. And the water was 2.7. So there, I just plotted high tide at 9:36. Now low tide occurred at 3:48. I need a decimal for 48 minutes. 48 minutes. Is that 0.8? Do 48 divided by 60, somebody. Is that 0.8?
It's 4/5.
Okay, but I can't say 3.8. What do I have to say if I'm in the afternoon? Think about military. Wouldn't that be 15.8? Right, because we're in the afternoon now. And that was 2.1. That's low tide. Assume that the depth of water is a sinusoidal function, a sine curve, sinusoidal, with a period of half a lunar day. So the period is 12 hours and 24 minutes. So that would be 12.2. I'm not sure about my arithmetic. Are you keeping an eye on it? 24, 6. All right. So if you think about this, can you envision a curve here, guys, that reflects the depth of the water during the day? Low tide, high tide, water going up and down. There it is. Now, they gave us a whole bunch of questions, and I think it's all going to pretty much depend on what the equation for that curve is. All right, so we're going to write an equation. And when I look at it, I kind of think of it as a cosine. Do you? So I'm going to write it as a cosine equation. I'm going to do exactly what we just did. Now be careful. This one has clearly been lifted up. Would you agree with me? It's supposed to be oscillating across the x-axis, but it's not. It's oscillating up here. Any idea where that pink line is?
2.4.
Oh, how did we get 2.4?
It's in the middle.
It's right in the middle. And that, kids, is your vertical shift. You've lifted it up 2.4. Now, what is your amplitude then? Your height of your waves is only 0.3. And for this particular equation, the part that I'm looking at, my phase shift is 9.6. Would you agree with that?
Yeah.
And the only thing left I have to figure out is the period, or not the period, but this number that controls period. But here's the good news. Didn't they tell me the period? So 12.2 equals 2 pi divided by my mystery number. So 12.2 n equals 2 pi. N is 2 pi over 12.2. Can I reduce that at all? Pi over 6.1. Are you okay with that equation based on what we drew? Okay, let's answer some questions. At what time on the 4th of July did the first low tide occur? Now, be careful, because I only plotted what they gave me. It's possible that there was my picture's not very good, but it's possible that there was a low tide before this. Would you agree with that? I'll move this over here, okay? Now, this is a low tide. Does it make sense to you that whatever this distance is, if I backed up that far, there would be another low tide over here? So what's that distance right there?
6.7.
Is that 6.2?
Yeah.
So if I back up 6.2, I'm going to be at 3.4? Now what time does that represent? That's 3 in the morning,
3:24.
and then 4 more tenths, which is 2/5, 24? 3:24 a.m. What's the matter, Carol?
She got it, she figured it out.
She figured it out? What was the approximate depth of water at 6 a.m.? Now, would you agree, oh here, let me go ahead and continue this. Would you agree that somewhere in here is 6 a.m., 6.0? And I want to know what the depth of the water is? Now, kids, you have an equation. What do the x values in your equation stand for? Aren't these the x's? So what if I put 6 right here? 6 a.m. would be 6.0. What if I put 6 right here and type this into my calculator? I cannot find my calculator. So let me work for it here. Go ahead and put in 6 into that equation. Make sure that you are set in radians. Okay? Be sure that you are set in radians. So radians, yep. So 0.3 cosine pi divided by 6.1 6 minus 9.6 plus 2.4. I am not sure I took that. Divided by 6 times negative 2.4. Did you get about 2.3? So what does that mean? At 6 a.m., the water was 2.3 feet deep, or meters, whatever it is, meters deep. So when I typed it in, I went ahead, I made this negative 3.6. I took this, divided by that, times that, took the cosine of that, times 0.3, and added 2.4, and this is what I got, 2.316 is what I got. What would we do if we were doing 3 p.m.? Same thing, except we would put in 15, right, because it's p.m.? What was the first time on July 4th when the water was 2.4 meters deep? That would have been right here, wouldn't it? Or, wait a second, is there a time before that even?
Yeah, it's like 12:58 or 12:56 or something.
Yeah, because
Or
6 is not part of
48.
this conversation.
48.
But from here to here, the midway point would be, what?
6, right?
6.1? No, no.
6.0.
6.5. No. Help, what's the midpoint?
It's 6.0, right?
I don't think it is it?
Thought it was.
No, it's actually 6.5.
Because we found the depth when it was at 6 a.m. and it was at 2.4, right?
No, it's 2.3. So this, I think, is 6.5. So that's a distance of 3.1. So if I back up another 3.1, it's going to be a 0.3. And that's 3/10 of 60, which is 12:18. Yeah. So at 12:18 a.m. That's what it is. When am I ever going to use math in my life? Well, you may not do this, but somebody does this, right? Somebody does that. All right, 4.4.